Good morning guys and welcome to Mind Your Math. Today we are going to do a very important geometry chapter of grade 9 and that is circles. It is not a small chapter, it is a little bit of a lengthy chapter. Let us say it has got around 11 to 12 theorems in it. This chapter on circles is mainly about theorems and their proofs and how you can apply those theorems in the numericals that will be given to you. Okay. Now, most of the theorems in this chapter, the proof of those theorems are actually very easy. They are basically based on congruences, which you have already done in grade 7. So it is not a very head-breaking thing to learn the proof of those theorems. We will learn the theorems and the proof, and then as and when we move on with each and every new theorem, we will be doing the sums based on those theorems so that you get a clear understanding of the theorem and their applications also. So as usual, I am telling you, any doubts regarding the content of this video, you can reach me at the mail ID given below in the description box. Now let us start this chapter with a few definitions that you already know. We will start with the definition of the circle. I am following the definition that is given in your NCERT textbook. If you check up different websites or if you check up even different reference book also, you can find that circle is defined in a wide variety of ways. But since you are going to appear for a board examination, I will as well stick to the definitions given in the NCERT book. So it says that circle is a collection of all points in a plane which are at a fixed distance from a fixed point in the plane. Okay, so this is how we normally represent a circle. You also know that the circle has got a center. These are all basic things that you have already learned in your lower classes. Correct? I am representing the center of the circle by the letter O. Okay, now you know that the distance between the center and any point on the circle is fixed. From whichever point you are taking on the circle, this distance will all be the same. Correct? So this distance is called as the radius of the circle, normally represented by R. Now let us get to the definition. The collection of all points in a plane. So this is a plane and collection of all points. These are basically points in a plane which are at a fixed distance. Fixed distance from a fixed point. Fixed point is our center in the plane is called as a circle. Suppose you have a point O and you are plotting a set of points in the plane which are at a fixed distance from this particular fixed point. This forms a circle. That is our basic definition. As you very well know, that fixed point is called as a center and the fixed distance is called as a radius. Now whenever you are representing a circle, we represent the circle as C is our circle, in the bracket, this is the center and this is the radius. Suppose we have another circle P. It basically means P is a circle whose center is denoted by X and the radius is given as P. Okay, so now I hope you are clear with the definition of a circle and what is radius and what is center and how to represent a circle in this form. Okay, so now let us get to the next definition which is relevant to the circle. Before we move on to the next definition of the circle, let me make a small point. We were talking about radius. Radius is the distance between the center and the circle. Okay, now you know that this is fixed. Now this radius, is it a line or a line segment? You can very clearly see that radius is a line segment because it has got two proper endpoints. Now this gives us two facts. One is that this is a line segment and one is that it has got a length also, which is a fixed length. Okay, remember these 2 points when we are talking about radius, that it is a line segment and it has got a particular length also. Now we will talk about the chord of a circle and also the exterior and the interior of a circle. Suppose you have a circle like this. This is the plane in which the circle is defined, right? Now this particular circle divides this whole plane into the part inside the circle and the part outside the circle. The part outside the circle is called as the exterior of the circle and the part inside of the circle is called as the interior of the circle. So you have 3 parts: interior, exterior and the circle itself. Okay. Now let us move on to the concept of chord of a circle. You have already learned in your lower classes. What do you mean by the chord of a circle? Chord of a circle is a line that joins any 2 points in a circle, however close those points are. Suppose you have a circle and you are joining any 2 points and naming it as AB. So AB is a chord of a circle. This is also a chord of a circle. This is also a chord of a circle. Now, what is the difference between AB, PQ and RS? If this is the center, X, you can see that the chord RS passes through the center of the circle. The chord passing through the center of the circle is called as the diameter of the circle, and you know that diameter is twice the radius. Now, in a circle, this is the center. Now, this is the diameter. This is a diameter. This is a diameter. This is a diameter. How many diameters can a circle have? Diameters are all of the same length, but how many diameters can you draw? We can draw infinite number of diameters. All that we require is that you just need 2 points on both sides of the center. So we can draw as many diameters as you want. Okay. So now we have learned the definition of a circle. We know what a chord is. We know what diameter is. What's the link between diameter and the radius and the interior, exterior and the circle itself. Now let us see another definition, which is called as arc of a circle. Here you have a circle with center O and radius R. I have not marked the radius. Now you know what a chord is. A chord is a line that connects, a line segment that connects 2 points on the circle, correct? So suppose you are taking any 2 points P and Q. You know that you can draw a chord, which is PQ. Now this particular 2 points P and Q divides the whole circle into 2 parts. Suppose you are joining a chord over here. You can see that this chord is slicing the circle into the upper part and the lower part, and both parts are unequal. One is a small part like this, other one is a bigger part. Okay. Now the piece of the circle between the 2 points is called as the arc of the circle. So I have an arc over here and I have a huge arc over here. The smaller arc is called as a minor arc and the bigger arc is called as a major arc, obviously. Okay. Whenever you have a minor arc, how do you represent it? It is PQ with an arc over it. When we are denoting something like this, we have to understand it is a minor arc. So how do you represent a major arc? When we are representing a major arc, what we do is that we take one more point over here, let it be X. Because the distance is more, we take one more point over it and we denote it as PXQ. So we need to understand that it is a major arc. Okay. So we learned what an arc is. It is a piece of a circle between 2 points. Now arc can be unequal arc. So it becomes a minor arc and a major arc. This is how you represent a minor arc and this is how you represent a major arc. Now suppose P and Q lies on as 2 endpoints on the diameter, or it lies on 2 ends of the diameter, then you can see that both the arc will be equal. There will be no minor and major arc, both are equal arcs. Okay, so a diameter basically divides a circle into 2 equal arcs. Each of these equal arc is called as a semicircle. So if somebody asks you to explain mathematically how a semicircle is formed, it is basically because when 2 points on the circle becomes the endpoints of a diameter, the circle gets divided into 2 arcs and the 2 arcs are equal in length, or 2 arcs are equal and each form a semicircle. Okay, so now you know the concept of semicircle and how the endpoints of a diameter basically divides a circle into 2 semicircles. Now let us learn about what a segment is and what a sector of a circle is. You have a circle with center O and the radius be R. Okay, suppose you have got 2 points on the circle and I told you that PQ is an arc of a circle and similarly PAQ is another arc of the circle which is called as a minor arc and the major arc. Okay, now if I am joining P and Q by a chord, this is our chord PQ, this is our arc PQ, the space between the chord and the arc, this is called as the segment. Similarly, the space between this chord and this major arc is called as another segment which is called as a major segment, and that part will obviously be called as a minor segment. So depending upon the arc involved, we can say that a segment is a major segment or a minor segment. Okay. Now Another thing, or sorry, another term that you need to study is the sector of a circle. These 2 points P and Q, suppose you are joining to the center. Now, this will be the shape. It is like a pizza slice. This is called as the sector of the circle. Now again, depending upon the arc involved, it is called as a minor sector, or if it is a major arc that is involved, we call it as a major sector. Okay, so we know what a segment is, and you know about a sector is, it is the shape of that of a pizza slice, and segment is a space between, it is almost like a not semicircle exactly, but kind of a semicircle kind of thing. So that is a segment, and the other one is called as a sector. Before moving on to the theorem that is mentioned in the NCERT textbook, I would like you to know a few theorems that becomes necessary just in case it is asked as a 1 marker or a 2 marker for your examination, or to have a better understanding of the congruency or the idea of superposition in circles. You should basically know these theorems. These theorems I have taken from the reference books. So let us start with the first before moving on to the theorem, the first concept. What do you mean by congruent circles? You know what is congruency? Congruency of triangles is something that you have already learned. When all the sides or when all the angles of one triangle become equal to the corresponding parts of the other triangle, they are said to be congruent triangles. What do you mean by congruent circles? Congruent circles are basically 2 circles that overlap each other perfectly or superimpose on each other perfectly. This can happen only when the radius of one circle is equal to the radius of the other circle. Suppose the radius of this circle is R and this circle is R1. For congruency, R has to be equal to R1. Okay, that is basically the idea behind the congruency of circles. What do you mean by the congruency of arc of a circle? When do you say 2 arcs are congruent? We say 2 arcs are congruent when the measure of one arc is equal to the measure of the other arc. Like we say, a line segment is congruent to another line segment. It happens only when the length of one line segment becomes equal to the length of the other line segment. Same with the case of this arc also. Length of one arc or the measure of one arc has to be equal to the measure of the other arc. Okay. Now let us learn about the degree measure of an arc. You have a circle, center of the circle, the total is 360 degrees because the total measure around a point is always 360 degrees. Suppose you have a chord PQ and you have an arc PQ. Okay, let me forget the chord PQ. Okay, you have the arc PQ. Suppose I am joining the endpoints of the arc to the center. You get a sector. Okay, but then PQ is an arc, and this measure over here, let us denote it by theta. This is called as the degree measure of the arc PQ. Okay, now whenever you have got equal arcs in the same circle, suppose you have got another arc RQ, which is both the arcs are equal, then the degree measure of both the arcs also will be equal. Or if the degree measure of 2 arcs are equal, then the arc also will be equal. So the degree measure is always connected with the total measure of the arc. If the degree measure are equal, the arcs are equal. Or if the arcs are equal, the degree measures are equal. This happens only in the case of the same circle or congruent circles. Don't apply it to 2 different circles and then proceed with the sum. It is only applicable for congruent circles or the same circle. Okay. Here is the first theorem for today. When 2 arcs of a circle or congruent circles are congruent, the corresponding chords are equal. Okay, so we are dealing with either a single circle in which 2 arcs are congruent, or we are dealing with 2 congruent circles whose 2 arcs are congruent. Now, what is given to you? We have been given 2 circles which are congruent. So when circles are congruent, we know that the radii of both the circles are supposed to be equal. So if the radius of this circle is R, the radius of this circle is also R. So my first circle is C with a center O and radius R. My second circle is C dash with the center O dash and radius R dash. I have got 2 chords PQ and P dash Q dash which are given to be congruent. Okay, what do we need to prove? Sorry, arc. Okay, what do we need to prove? We need to prove that the corresponding chords which are given by these 2 endpoints are also equal. Okay, now in order to start with this particular proof, we know that we have to make some sort of construction. Now, when we think of a circle, what is the first construction that always comes to our mind? It is always the radius or connected to the center, and try to start proving the radii. Try to start proving under the condition that radius of a circle will always be equal. So now let us start with the construction. Now I have made a note of the construction that we are going to involve in this particular theorem. I have joined P and Q to the center O, and similarly in the second circle I have joined P dash and Q dash to the center O dash. And whatever construction or changes that you are making in the diagram, you have to please mention it here, okay, before you start with the proof. Now, the problem with this kind of proof, or what I find a little tough when I am explaining the proof to my students, is that when I am talking about PQ and the arc PQ, the question obviously arises, am I talking about the small arc over here, or am I talking about the big arc over there? There are two situations, right? So I need to write the proof for both the cases when PQ is a minor arc and PQ is a major arc. So when PQ is a minor arc, P dash Q dash also will be a minor arc when we are dealing with it, because they have to be congruent. Then we have to deal with both of them being the major arc. So let us see how each of those conditions or each of those cases work. And trust me, this is a very easy proof, and only thing is that when you have to do it in two parts. You don't have to get very upset about it. Just carry on with the proof. It is very easy proof. It is basically only the congruence. So I have written down the proof for case 1 when PQ and P dash Q dash both are minor arcs. We know that OP is equal to O dash P dash. This is OP and this is O dash P dash. Because the circles are congruent, both of them are equal because they are the radii of each of the circle. Similarly, OQ is equal to O dash Q dash. Again, it is a radius. Now, angle POQ is equal to angle P dash O dash Q dash. The reason being, we already know the arc PQ and P dash Q dash are equal. Therefore, the degree measure of the arc, which is POQ and P dash O dash Q dash, they are also equal. We have already discussed about this. Now, the triangles are congruent by means of SAS congruence, side angle side. Therefore, PQ is equal to P dash Q dash because CPCT corresponding parts of congruent triangles. This is the proof when the arcs are minor arcs. Now, let us see the proof when arcs are major arcs. In the second case, we will take PQ as to be the major arc. So, I will make one more point over here. Let it be A and this be A dash. So, PAQ is a major arc of this circle, which is equal to P dash A dash Q dash, which is the major arc of the second circle. It is given that both are equal. We need to show that the chords PQ and P dash Q dash are equal. Okay. So, in a circle or in two congruent circles, if this part and this part are equal, my diagram doesn't look congruent, but they are congruent. If this part and this part are equal, the remaining arc also has to be equal, because the total measure of the arc is the total length, which is a circumference, and for two congruent circles it has to be equal, correct? So, if this length are equal, the remaining length also has to be equal. So, if the major arc PAQ and P dash A dash Q dash are equal, the minor arc PQ and P dash Q dash have to be equal. Okay. Now, we have already proved the situation wherein when PQ and P dash Q dash are equal, what happens? The chords become equal. So, we have proved the case when this is a major arc. Okay. Now, you are clear with this particular proof. I hope so. Let us move on to the next theorem. This is our second theorem, which is actually the converse of the previous theorem. See, the problem with geometric theorems is basically that every theorem has a converse and that becomes a theorem, and then we have to prove it. So, in the earlier case, we were given two arcs. We needed to prove the corresponding chords were equal. So, here we have got two chords which are equal. If two chords of a circle or congruent circles are equal, then their corresponding arc, whether it be minor, major or the semicircle arcs are equal, is something that we need to prove. So, what is given to you? We have got two circles with center O and O dash and radius R because they are congruent circles. And we have got two line segments which form the chords PQ and P dash Q dash, which are equal. So, I told you, whenever we are starting with a proof in circles, the first thing that the automatic thing that we do is connect the endpoints of the chord to the center. So, that is what I have done for the construction. Okay, we need to prove the arc PQ is equal to arc P dash Q dash. Let us consider the first case, the minor arc. Okay. Now, after doing the construction, what can you see here? You can see that. So, please mention the construction that you are doing over here before you start with the proof. So, you can see that OP is equal to O dash P dash, radius of congruent circles. OQ is equal to O dash Q dash, again radius of congruent circles. PQ is equal to P dash Q dash. It is already given to you in the question because that was our condition. So, you can say that both the triangles are congruent by SSS congruence. Now, both the triangles are congruent. I can also say that angles are equal. So, I can say angle POQ is equal to angle P dash O dash Q dash, which is the corresponding parts of congruent triangles. Now, what is angle POQ? Angle POQ is the measure of the angle which is made by this arc PQ. So, correct. That is equal to measure of. Okay. Now, since the degree measure of both the arcs are equal, what can I say about the arc? The arcs are obviously equal. So, PQ is equal to P dash Q dash. We got our first proof when the arcs are minor arcs. Now, let us see what happens when the arcs are major arcs or semicircular arcs. Here we have got that the measure of PQ, which is this. Let us call it theta. We got both these angles to be equal. Now, what can you say about this angle? This is 360 minus theta because the total angle around a point is 360 degree. So, this angle is 360 minus theta. Similarly, here also it is 360 minus theta. This 360 minus theta is the angle degree measure of the major arc. Since the degree measure of the major arc, both are found to be the same. What can I say about the arc length? I can also say that the major arc PQ is equal to the major arc P dash Q dash. You can put, so major arc PAQ is equal to major arc P dash A dash Q dash. So, it is the same case with the semicircle also. So, we have proved this theorem also. So, let us see what we have learned so far before we move further. Let us see what we have learned so far. We first started with the definition of a circle. Then you learnt about radius, diameter, all those terms you already knew. Center, chord of a circle. Then we started with a new term which is arc of a circle, which is piece of a circle between 2 points. Then we learnt about the major arc and the minor arc. Then we learned about the segment, which is the space between the chord and the arc of a circle. Again, we have got major segment and the minor segment depending upon the arc that is in question. Then we learned about the sector, which was like a pizza piece, and then we learned about the major sector and the minor sector and circumference of a circle, which we already knew. We also learned about the interior and the exterior of a circle. Okay. Then we learned about congruent circles. Two circles are congruent if they can be superimposed on each other. This will happen only if they have equal radius. So, two congruent circles will always have the same radius. Okay. Then we learned about congruent arc. Two arcs are congruent only if again they can be superimposed on each other. Degree measure of the arc. So, when you have a circle and you have an arc PQ, okay, this is the arc PQ. This is the degree measure of this arc PQ. We learned about what is the degree measure of an arc. We also learned that congruent arcs have equal degree measures in congruent circles. So, if you have got two circles and PQ is an arc and P dash Q dash is another arc, and their degree measures will be equal. Okay. And if two arcs have got same degree measure in congruent circles or the same circle, I can say that the corresponding arcs are equal. Okay. Then we learned two new theorems based upon all these basic concepts. It is that if two arcs in congruent circles are equal, the corresponding chords are equal, and the converse of the theorem which states that if two chords in two congruent circles or the same circle are equal, the corresponding arcs are equal. So, we basically equated degree measure, arc and the chord of a circle. Now, we move on to the first theorem in the NCERT textbook, which is equal chords subtend equal angles at the center. Okay, that is so here I have written the statement of the theorem. I have drawn the diagram. I have written the given and the to prove part of it. Now, in the textbook, they are talking about a single circle, but we know that we already did this for two congruent circles when we were proving the equality of the chord and the arc. But anyway, let us do the theorem as given in the textbook for a single circle. You can extend it to two congruent circles by mentioning that the two congruent circles have the same radius. That is the basic meaning of congruent circles, and then proceed with the proof as we did in the previous two theorems. Okay, so now let us do this. It is given that PQ is equal to RS. We need to prove that this particular angle and this particular angle are equal. That is the angle subtended by the chord. So now we know that OP is equal to OQ is equal to OS is equal to OR. What is the reason? They are all the radius of the same circle. So we can say that, and PQ is equal to RS is already given to you. So you can say that the triangles POQ and ROS are congruent by SSS congruence. Now, because two triangles are congruent, the angles, these two angles, ROS and POQ, form CPCT, corresponding parts of congruent triangles. Hence, they are equal. Okay, that is the first theorem given in the NCERT textbook. So, obviously, the next theorem will be the converse of this theorem. So, what is the converse of this particular theorem? If the angle subtended at the center by two chords are equal, then the chords are also equal. Okay, now let us take the proof of that theorem. So I have written the fourth theorem. If the angle subtended by two chords at the center of a circle are equal, then the chords are equal. So I am not even changing the diagram. Please mention the construction that you are doing, which is joining OP, OQ, OR and OS. Okay. Now let us start with the proof. This is also the proof that we had done for the chord and the arc, but let us apply it here. We have a circle and it has been given that POQ is equal to ROS. We have got two triangles. How will you prove the congruency? OP, OQ, OR and OS are equal because they are the radii of the same circle. Included angle is also equal. Therefore, both the triangles are equal by SAS congruence. And because of that, RS and PQ become the corresponding parts of congruent triangles and hence they are equal. Okay. So, before moving on to the next theorem, I want you to have a look at all the four theorems and understand each one of them clearly. Because these two theorems I have taken from the NCERT textbook, they dealt with the same circle. Here, we had dealt with both the options same circle and congruent circles. We had taken two different circles and then drawn the diagram. You could draw it in the same circle itself, which we did for this one. So this can be extended to two circles as well by taking two chords of equal length like this. Okay, so now I hope that these four theorems are very clear to you. The proof is more or less the same. Only in the first case, because there is an arc involved, we are talking about the degree measure of the arc to show that the arcs are equal when the degree measures are equal. Let me concise what we learned today. We are talking about the same circle or the congruent circles. The degree measure of an arc basically is the angle subtended by the respective chord. That is one thing that we learned. The main thing was that the degree measure is related to the arc and it is related to the chord, and equal degree measure ensures equal arc and equal chords and vice versa. Again, please remember, we are talking about the same circle or congruent circles.